Now, let's talk about the rules in addition and subtraction for a second. All right, I'm going to make up some numbers here. 100.5, 32, 101, and 10. And we're adding. In addition, it's not as simple as just saying, well, I have 1, 2, 3, 4, and notice these zeros were measured because they're in between two other digits that were measured. Obviously, if you measured this one and this one, you can measure those. So these are all significant, 1, 2, 3, 4 of them. 4 measured digits. 32, we have 2 significant digits here. 101, well, there's 1 and 1, which both of those obviously were measured. The 0 is in between them, so it's significant. 10, oh, remember about that decimal point. There's no decimal there. So we did not measure the ones place. We had something that was 10 long, and we used it, and something was about the same length as it. And that's what we got. 1 digit. When we add up, we need to look going to the right and see where our significant figures stop. In other words, this one has significant figures all the way to the tenths place. This one to the tens place. This one is, or sorry, ones place. I keep on calling it tens today, I apologize. Ones place, tens place. Now when we add it up, we can't keep anything to the right of the tens place because this measurement right here didn't have any value. So it's like saying whatever, because we really don't know what the number was, plus 1. What's whatever plus 1? It's whatever. We don't know. We didn't measure it. So we can't add it. We can't add something that we didn't measure to something that we did. It just doesn't work. So we'll go ahead and add these up. And we could look at this side and see if it rounded up here, but technically there's going to be a 5, and here we're going to have a 3, and a decimal right here in between, and then here we're going to have a 4, and here we're going to have a 2. And we can only keep 2 digits. So, in our answer, it has to stop at the tens place. So it's 240 is our answer. That 0 not being significant. So I won't put a decimal there because we did not keep that digit as being a significant digit. Now, it seems kind of tedious, and I know it's probably not your favorite thing right off the bat here. But this is very important, and I will be knocking points off if you don't do it correctly. That's why it's important, if for no other reason. But it really is important. You can see here, if we had one garbage number, you can't add a garbage number to all these numbers that you measured very precisely and get a very precise answer. It just doesn't work that way. So our answer is not very precise. It's only as good as the piece of garbage that we threw into it. A cake is a cake, and it's all wonderful, but you put cat poop in the cake, it ruins the whole cake, right? Well, there's the cat poop. No matter how good your measurement is, it's ruined now. So it's only as good as the least significant one that we're looking at, as far as how far to the right it goes. So addition and multiplication are a little bit different rules, and subtraction you follow the same rule. You only keep where your significant digits end going right. And division, same rule as multiplication. You figure out which number is the least number of significant digits in it, and that is how many you keep. Alright, quick little eraser break here. One more. Let's say, and this will show you how this plays in one more time. We already did length and width on this. So we had 37 centimeters long and 23.4 centimeters wide. I'm going to put those numbers back up here. And 23.4 centimeters. Let's say we wanted to find not just length times width now, but we want to find the actual volume of space taken up by the piece of plastic. That's, if you remember right, length times width times, what is it, class? Height, thank you, you're good. Equals volume. And hopefully that fits on the screen there. It's probably off the end, I can't tell. Anyway, length times width times height equals volume. Well, let's measure the height then. If we lay this flat, the height is this way. And this could be tricky to measure, as you'll see when I get up here. Okay. It's very thin. It's not that thick. Yeah, the height is not that great. Well, we'll try and take a measurement here. We'll put it right up against the ruler, and I get 2 millimeters. 2 millimeters, which is 2/10 of a centimeter. We'll write them all in centimeters. So 0.2 centimeters. And this is our length, our width, and this is our height. Now when we do our math on it, remember we can only keep the number of digits in the answer that we had in our least significant number going into the problem. So we have our 37 again, times our 23.4, times 0.2 equals, ran out of space on the board there. Well, let's see what it equals. 37.0. The answer is 173.16 centimeters cubed, which again is a lie. Calculators lie. Don't trust them. Well, trust them in some things but not in others. They don't know significant figures. We can keep how many digits? Just one, because that's all we have here. Our measurement was garbage, really. We only had 2 little marks here, and that's all we could see. So, with 2 little marks and that's all we can see, that's not a very good measurement. And that's not very close to the camera. That's all we can measure. So since that is a garbage measurement, it's going to end up making everything here garbage as well. Remember the cat poop analogy. So, we can only keep 1 digit here. What's the digit we want to keep? The biggest value. So when we figure this out, that's the digit we want to keep. Does it round up? It does. So it ends up being 200 centimeters cubed. Again, those zeros are placeholders. They're not significant. So we don't put a decimal place there. And again, not just to confuse things, but to show us how accurate our measurement really was. When we do a calculation, we could end up with our calculator telling us, hey, you guys measured 5 digits. No, we didn't. We measured 1 digit. And we can only keep 1 digit. So that's why we do it. Any questions? You ask me.